Welcome to our discussion on graphics in the media. So, different types of graphics. You're going to see multiple bar graph, where you have two or more sets of bars that allow you to compare two or more sets of data, right? Also, a multiple line chart does the same thing, but with lines instead of bars. And then a stack plot shows different data sets stacked upon one another. In my opinion, these are terrible and they're confusing, and I would avoid using them. And if you come across them, good luck trying to determine what the heck they say. So here's a sample of a multiple bar graph, right? Where you have to look at the legend, right? And the red color is men, that kind of peach color is women, and it gives you all the different degree types, and then you can see the differences in average salaries, or in this case, median salaries between the genders. So you can see that no matter what level of education, men are earning more than women, and that's a problem that we've seen, time and time again. And then you've got unemployment rates, and each line represents, different levels of education, right? So as you go lower, it's more education, which makes sense, hopefully, that, the more educated you are, the less likely you are to be unemployed. And you can see that even when there are spikes in unemployment, the people with higher degrees suffer less, so to speak. So those are some of the things that we can see from those displays. Then here's the stack plot. I hate these, right? Each colored spot is supposed to, be relative in size. So this at 7,400 is a little bit bigger than twice of this, but unless everything's labeled, it's really hard to figure out what's going on. So I don't like stack plots at all. I'm also not a fan of stack line graphs, because again, it's hard to figure out what the totals are, what each zone represents. So I would avoid those if you can, because they're just, I don't think they're easy for the average reader to understand. Then we've got graphs for geographical data. You've got just, regular old maps with different colors to represent things. Here it's per person energy use by state, so like gallons of oil equivalent, and you can see that kind of the bluer colors are using more per person, and the lighter colors are less per person. But that can be very misleading because, states like Wyoming and Alaska don't have a lot of people, whereas California and the Eastern Seaboard have a lot of people. So even though this is a low level, right, amount of energy per person, these states are probably using a lot of energy, right? So it all depends on how you want to look at the data. Then you've got contour maps where you get these weird contour lines that represent different things. This one happens to represent temperatures. So you can see the cold in the north, right, warm in the south. I'm sure you've seen these before on weather reports. So you can get all sorts of information from those by looking at them. Then you got three-dimensional graphics. Now, they say three-dimensional graphics are great because it gives you a richer picture, but I think they can become misleading because it can overemphasize differences. Because you look at something and go, well, it's three-dimensional, so there's a lot more volume to this than this. But you're not comparing volumes, you're just comparing heights, is what you should be doing, right? So three-dimensional ones can be misleading very easily. And so that's what brings us to the last couple slides where we talk about cautions about graphics and how they can possibly be misleading. So the perceptual distortions. So oftentimes graphics are drawn in a way that distorts our perception of them, and I think three-dimensional graphs is a great example of that. You got to pay attention to the scales. Sometimes it can be very visually deceptive if you don't see what the scale is that they're using. Percentage change graphs. Graphs that show percent change can be misleading unless you interpret them with great care, right? Because oftentimes percent change can seem like a big deal when it really isn't. And then pictographs are oftentimes very misleading. And so here's your perceptual distortion, right? The lengths of the dollars represent the data, but you tend to focus on the area. So you look at this one to this one and go, God, that's twice as big, and this one to this one, that's like almost 3 times as big. But you're not supposed to look at area, you're just supposed to look at the lengths, right? When you look at the lengths, they're not nearly as big of a difference. Vertical scales makes a huge difference. So these two graphs represent the exact same data set, but doesn't this data seem far more violently changing than this one? And that's because instead of having the vertical scale that starts at 0 like it's always supposed to do, they just basically cut it down and zoomed in, and they started at 30 and they went from 30 to 60. So it looks like you have these huge differences, but in reality, this is just going from 40 to 47 down to 30, right? It's not huge differences in the overall scale. So that's a very common way to mislead. And then different horizontal scales is a problem because it appears that the world population has been rising linearly, right? This looks like pretty much a straight line. However, the time intervals on the horizontal axis are not uniform, right? So they went from 1804 to 1927 to 1960. So the horizontal scale keeps changing. So it makes it look like everything is growing linearly, but it's not because the differences, right, are different each time. So just pay attention to things like that so you don't get misled.